Hello class. Today we're going to talk about two-step inequalities. But let's first do a little bit of review. Okay, so on your warm-up today, let's talk about the two-step equation that's here and the one-step inequality. Because in our lesson today, we're going to marry these two together. So with an equation, we know we have three basic steps. Step number one, get the letters on one side. Step number two, get the numbers on the other side, and then solve. Well, in this particular problem, our variables are already together, so I don't need to worry about that one. So the first thing I'm going to do is I'm going to change my subtraction to addition, next number to its opposite, and now I'm going to move this -4 over to be with the 25. And the way we do that is we add its opposite. So 2x plus -4 plus 4 equals 25 plus 4. Okay, because the new thing I added on the left was 4, so I have to make sure I add that onto the right as well. So now I simplify this line, and I end up with 2x is equal to 29. Now I have a multiply by 2. To get rid of the multiply by 2, we do a divide by 2, and we end up with x equaling, and now 29 divided by 2 gives us 14.5. And this shows that not all problems will come out nice. Now this one's not too bad, but it's not one of our perfect answers either. Now let's look at the inequality. Now in this inequality, you'll notice that the letter's on the right-hand side, and some of you may not like that. It is okay if you want to flip it if you want to, and that's okay. I'm going to leave it the way it is, but this is what you would do if you wanted to flip it. You would take the x minus 9, and you would write it down. You would take the 8, and you would write it down. Now we need to remember about this inequality. If it was an equals, it doesn't really matter. But with the inequality, we got to make sure that it's still eating the same thing. And you'll know that the mouth opens up to the 8, so we have to do the same thing. So it's now, when I flip it, a less than problem versus a greater than problem. Now I'm going to keep mine the way it is. So the first thing I see is I'm going to change my minus to a plus next to its opposite. And just like with the equations that we did, I'm going to start at the inequality. And I need to move the -9 over to be with the 8. So the way we do that is add its opposite. So x plus -9 plus 9, and then 8 plus 9 on this side, making sure that I add the same thing to both sides. And we end up with 8 plus 9 is 17 is greater than, and on the other side, our 9's go away, and I'm left with x. Now, I prefer at this point, if I want to flip it, to flip it. All right? But let's look at what this says, because we now need to do a graph. Okay, so we're going to do a quick graph, so I'm going to put 17 underneath. Now the first thing we look at with an inequality, is it going to be an open circle or a closed circle? Well, this one, since it's just an inequality there with a greater than or less than, it's going to be an open circle. If it were an equal to with a bar underneath it, then we would close the circle in. Now this one says that 17 is going to be greater than the value of x. Or you can also read it the other direction, x is less than 17. So that means I need the values that are to the left of 17. And some of you are going to say, but Mr. Nash, you told us that that inequality is going to tell us which way to shade. I also told you that it's going to tell you which way to shade only if the letter is on the left. So if I were to flip this, x, then 17, the inequality is eating the 17. Now it shows, oh, and I forgot to flip it there. Oh my goodness. So I flipped everything, but not that one. So now if I take this and I flip it, okay, which is this way, now it does show the direction that you're supposed to graph it. So it only works if the variable is on the left. Does the inequality tell you which way to shade? Now what we're going to attempt to do today is put those two things together, and we're going to look at two-step inequalities. So I have a question for you. Would two-step inequalities be worked the same way two-step equations are? Well, the answer is yes, they will be. They'll be worked the same exact way. Step number one is get rid of the addition and subtraction by adding the opposite. Then get rid of your multiply divide by doing the opposite. We just have to remember one thing. If the coefficient is negative, you're going to have to flip the inequality. So let's see if we can work just a few of these. We're going to work 3, and then we'll be done. So here's our first one. 2x plus 5 is greater than 7. Well, again, our steps are get our letters on one side. They are. Get our numbers on the other. So we have to do that one and then solve. So to move the 5, we're going to add its opposite. So 2x plus 5 plus -5 is greater than 7 plus negative 5. So now we simplify those lines, and we end up with 2x is greater than positive 2. Because if our signs are different, we subtract. So now I have a multiply by 2, so we do a divide by 2, and x is greater than 1. Since my coefficient was positive, my inequality does not flip. So to do a quick graph of that, then we'd come over here, we'd put a little hash mark on the graph, put a 1 underneath it. Okay, and since this is just a greater than symbol, it's going to be an open circle, and I'm going to shade to the right because I need values greater than 1. Okay? So what if we had one like this? Now immediately when you look at a problem like this and you see that the number with the variable is negative, you know we're going to have to do something at the end of the problem. So keep that in mind. Okay, so we start off the same way. Okay, our letters are together on the left, so I want my numbers together on the right. So I'm going to change my subtraction to addition, the 12 to a negative. Now I need to move the negative 12. So negative 8x plus negative 12 plus positive 12 is less than 12 plus 12, because the positive 12 was the new thing that I added on the left. So my 12s go away, and I'm left with negative 8x is less than 24. And now we come to this step. Okay, I've got to divide by a negative 8. Divide by a negative 8. So if I divide by a negative number, my inequality is going to flip. Okay, so the 8's cancel out and are left with 1. The 24 divided by negative 8 gives me negative 3. But I need the values not less than that, but greater than the negative 3. Okay, so if our inequality, if our coefficient is negative, my inequality is going to flip when we do that step. So now if we did a quick graph, put a negative 3, it's going to be an open circle, and I need to shade to the right because I need values bigger than negative 3. Now if you were to check that, you could plug a number back in that fits into that criterion. We would see that it works. So let's try that. So I need a value that is greater than negative 3. Well, the value that I know is the best that's greater than negative 3 is 0. Okay, so if we were to plug that in, negative 8 times 0 minus 12, is that less than 12? Well, negative 8 times 0 is 0. Minus 12 gives us a negative 12. Let's see if I can write that better. Is negative 12 less than positive 12? And yes, it is. Now we have one more problem to do, one more to look at, and then we'll be done. What if I give you one with division? Do you do it the same way? Yes. You still move the 5 over to the other side because our letters are together. And then I have a divide by 3, so we do a multiply by 3. So let's see. X divided by 3 plus 5 plus negative 5 is less than or equal to 9 plus negative 5. So we end up with x over 3 is less than or equal to 4. Now how do I get rid of the divide by 3? We do a multiply by 3 and a multiply by 3. So x is less than or equal to 12. And again, since my number here was positive, then I don't have to flip my inequality. So now to do a quick graph, we come over here, we put a 12. Now this time it is a less than or equal to, so that means we do a closed circle on 12 and we shade to the left. And that's how you solve two-step inequalities.